So let's look at this question here, which is on Maclaurin series, I believe. This is a past year question. Paper 1, question 8. Let's see how I can do this proficiently. So you're given that y is equals to fx. Alright. And where fx is equals to tangent ax plus b. And a and b are constants, so that's pretty okay. Show that f prime x is equals to a plus ay squared. Okay, that's pretty okay, I think. So I'm going to do f prime x, which is b secant square ax plus b times a. Chain rule. Remember chain rule. So the outer layer and after which the inner layer. Right. So you take the outer layer out. This part here. Then after which you multiply by inner layer here. Great. So once this is done, what we need to do is actually show that it's actually a plus ay squared. Now what I need you to understand is essentially you can change secant to tangent, right? The y will come. Secant and tangent square are actually very closely related. So whenever you see secant square, you must think of tangent square. But in the exam, you are not given this formula here. So I think I'll just write it down. Cosine square a plus sine square a equals to 1. So you need to know how to derive it. Actually divide both sides by cosine square a. And you will get 1 plus tangent square a equals to secant square a. Okay, that's the first thing I will do. So just secant square is actually 1 plus tangent. So this will be 1 plus tangent square ax plus b. And I'm just going to replace the whole thing with a. This a I'm just going to put in front. Okay. So there you go. So once this is done, we could actually replace this with y square. This is my y square. That's it, I think. So this is a plus ay square. Shown. Okay. It's good. Then after which use this result to find f prime prime x and f prime prime x in terms of a and y. Okay, that's pretty okay also. So what we're gonna do is actually just gonna put f prime x is f prime x, right? So you use this result here. So differentiate this with respect to oh, there you go. Y is okay. That's interesting. So in terms of y, this is y, right? So f prime prime x will give you 0. This is a constant. Then this will be 2a y dy dx. Okay. And now y, because you want it in terms of y, but this is actually this is actually dy dx, right? This is dy dx. So what do you do is from here, dy dx, this is actually my f prime x. Okay, this is my f prime x. But the f prime x here is also, because we want in terms of a and y, so I'm going to substitute f prime a. This is 2ay. And this will be a plus ay square. Interesting question. Love this question, man. Plus 2a square y cube. Interesting. So this is you. So I got my f prime x already. So this is 1. After which you're gonna find f prime 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 x. So differentiate this again. So the f prime 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 x, and this will be 2a square dy dx plus 6a square y square dy dx. Implicit differentiation. And I'm going to replace my dy dx again with a plus ay square. This is plus 6a square y square a plus ay square. Okay. This will be 2a cube plus 2a cube y square plus 6a cube y square plus 6a cube y4. That's it. Oh, sorry. Oh, plus a lot. Used to it. Okay. So this is how you do this question here. This is how you do. Sorry, this is how you do this question here. This is 8 cube y square. Yeah. So it is a bit confusing because of what not the conventional, but it's basically just algebraic algebraic manipulation and know what you're told to solve. Okay. So that's how you do this. Any question, let me know. Let's look at the subsequent part. So let's look at part 2. Part 2 in the case where you're given that b is equals to 1/4 pi. You are told to find fx in terms of a and x till x cubed. Okay, so now let's see and understand what is going on. First thing is I'm just going to sub in the b in so that we will understand the situation. Is a tangent ax plus pi over 4. Okay, but the problem now is because if you want to find f prime x, right, you need to be able to find what's the y. And because we do not want y in this case here, it's obvious that we do not want y. So you need to find out what is y in terms of b, right? Because all these are in terms of y here. So I think it's pretty okay. Y is my fx. Okay. In this case here, if I were to use y when x equals to 0, because I need it x equals to 0, the expression here for fx is using Maclaurin series, right? So I'm going to bring out the Maclaurin series here. So this is the Maclaurin series from our MF26, and you realize that to find fx you need x is 0, and also now that we have b equals to 1/4, so we're just gonna go through the quest of finding each and every one. So f0 will just be tangent 0, x is 0 plus pi over 4, and this will give us 1. Okay, that's pretty okay. Then after which, what we're gonna do is actually this is when y goes to 1, right? So f prime 0 will then be, we're just gonna replace this in, f prime 0 will just be a 1 plus 1 square, because this is actually my y is actually 1, right? So this case will be 2a. That's pretty okay. Then of which if f prime 0, f prime 0 is here, this one here. So I'm gonna just put 2a square 1 plus 2a square 1 cube, which will give us 4a square. Okay, that's pretty okay. Then after f prime 0 would just be f prime 0, 2a cube plus 8a cube plus 6a cube times 1. All the y's are 1. When x is 0, y's are 1. So this will give us 16a cube. Then using hence fx, right, will just be f0, which is actually 1, plus 1 times f, so it's 2ax plus x square over 2 factor f prime, which is 4a square, plus x cube over 3 factorial, which is 16a cube. Okay, so key in calculator, I think this would just be 1 plus 2ax plus 2a square x square, 16 divided by 6, which is 8 over 3, a cube, x cube. That's how I do this question here proficiently. Yep. Let's look at the last part, alright? So let's go to the last part. The last part we are told to find tangent 2x, okay? Tangent 2x will be tangent ax plus b. In this case here, b will be 0 and a will be 2. Let's see whether if we sub b in is 0 will be easier. I think it's pretty easy though. So then we can find, okay, so this would we could sub b 0 in, so that it will be quite fast, I believe. So when b is 0, tangent 0, so f0, so x0, f0 will be 2x 20 plus 0 tangent, right? Tangent 2a plus b, so tangent 2 0 plus 0. So this will be 0. I think this will be the fastest way, because now pi over 4 you could see that it's quite fast, right? So f prime 0 will be even faster. F prime 0 will be, we just sub this in and we know that y is 0, so we'll be left with a. F prime 0 will just be 0 0. Oh, this is 0. F prime 0 will just be 0 so it's 2a cubed. Okay, which is 2. The a will be 2 because this is 16. So hence tangent 2x will be 0 0 this is 1 plus 2 times x, so 0x plus 0 I'm not sure why I'm not thinking straight, so let me just bring this out. So f0, this is 0 plus x f prime 0, which is 2, plus x squared over 2 factorial f prime 0, which is 0, plus x cubed over 3 factorial, and this was 16. Okay, that's pretty okay. I think you get the first two non-zero terms here. So this will be 2x 16 over 6, which is be 8 over 3. Alright, it's pretty clear-cut way of solving. Yeah, any question, please let us know. Keep practicing, and I will see you in the next question.